Welcome to Pure One, Chapter 10.4, where we are actually using the cost diagram to help us to solve simple trigonometric equations. When you say simple, of course, there are harder ones. The next chapter, next lesson. So, this lesson, you will be learning quite a lot of solving equations of trigonometry. This will become the basic of what you can learn moving forward in A level as well. So, this lesson is kind of important if not all of them are important enough. Anyway, so notes in here. So the equation, let's say we've got sine theta equals k, okay, and cos theta equals k are only solvable between when minus 1 to 1. So what it means is sine theta and cos theta is bound between 1 and minus 1, which we know that, right? So this is just a technical definition of sine theta and cos theta being bound between minus 1 to 1. We know that. And we also know there are more than one solutions to most trigonometric equations, to most of them. Now, can you think about why is it most of them, but not all? If it's between minus 1 and 1. Because now you can see in here, if y is 0.7, we've got two solutions. But what if y equals 1? Then we only have one solution from 0 to 360 degree. Obviously, it was from 0 degree to 360 degree. Okay, then we'll have only one. So yeah, so the sun say I've only got an answer to that says it's a trick equations. They cry together, of course, like a teacher and student. Right. So what could help us to find out all solutions? Obviously, the Cartesian diagram, and hence the importance of learning how to use the Cartesian diagram because we'll be using it today. If you forgot how to use the Cartesian diagram, I would suggest you go back to the previous lesson on 10.1 to 10.2, where we learn about how we use the Cartesian diagram. Okay. Right. So that's the previous lesson. Right. Okay. So without further ado, oh, by the way, use cast diagram. This very, very important. Highlighted. Okay. Use the cast diagram as soon as you arc sine or inverse sine, inverse cos, inverse tan. So I think I did mention arc sine. Basically, arc sine. This is the inverse of sine. You've learned about in GCSE something. This is called inverse sine, but the proper mathematical name is called arc sine. So if you want to do inverse sine of 0.5, okay, we can say arc sine 0.5. You can actually write arc sine, but not now because arc sine usually we use in algebraic context for solving algebra, usually used in further maths. So I don't worry about that one. So inverse sine, if I say arc sine, it's just the same thing. Inverse sine, arc cos, arc tan. So this is the steps of using cast diagram from 10.2. I'm not going to go through it again. So you can read it when you need to. Right. Example, find the solutions of the equation sine theta equals a half where the interval is between 0 to 360 degree. So first of all, to work out theta, we do inverse sine on the other side, inverse sine a half. Okay, so inverse sine a half. So here, that's when we have to use the cast diagram. So next step, we need to use cast. Okay, so to use cast diagram, hopefully you remember you've drawn a pair of axes. Okay, step one, so draw a pair of axes. Oh, actually, before we do that, actually, sine theta equals inverse sine of a half. Put in a calculator, inverse and a half, please. Inverse and a half, you should get 30 degree. Let me double check, my mental math sometimes not working perfectly fine. Inverse sine of 30 degree, or inverse sine of 0.5 is indeed 30 degree. Okay, next, we draw 30 degrees. So remember cast diagram, so CAST in here. Okay, so in the all region with 30 degree. So when is sine being positive? Sine is being positive because it's positive half means we're reflecting in the sine quadrant. So we're reflecting in the sine quadrant, right? So 30 degree. Last step, we count from the 0 degree angle, so 30 degree, and this one is 150 degree, I believe. Therefore, theta, okay, so theta equals 30 degree or 150 degree. That's how we find both. If you know a cos diagram, you would find this quite familiar. Okay, so if you put in a calculator to double check, okay, so double check, okay, double check. You can do sine 30 degree, okay, which equals a half. Check. Sine 150 degree also equals a half. Check. Okay. Now, what if, okay, what if you replace you reflect in the wrong quadrant? Okay, so let's say you reflect in here. Let's say, for example, or let's say in here. Okay, so that's the wrong answer, by the way. Just to for those who are just pausing, just suddenly randomly landing on this second of the video. So in case if there's a wrong answer, just want to make sure. Okay, so wrong answer. So this will be 330 degree. If you try putting a calculator, sine 330 degree. okay, sine 330 degree, you get negative a half. Why is it negative? Well, because in this quadrant, sine is negative. That's why it's negative a half. So we know that's wrong. Okay, so that's how you double check your answer. Okay. Um, so there are normally two answers from the region from 0 to 360 degree. Okay. Because if you look at the previous diagram, you get two. Yeah, 1, 2. All right. So next one. Find the solution of the equation tan theta equals minus a half. So let's do that. First step, inverse tan of minus a half. So put in the calculator, inverse tan or arctan of minus a half is 26.6 degree again. So negative 26.6 degree. Okay, so negative 26.6 degree. So next, we need to do a cast diagram. So cast, okay, so do a cast diagram. Negative 26.6 degree is here. Let me use the blue, okay, in here, because it's negative degree. So we must go opposite direction. Now, we don't put negative in here because the negative already tells us to do this way. If it's positive, we go that way. That's why we don't put negative. The angle, the size of the angle itself is 26.6 degree. So which other quadrant is tan negative? Sine. So reflect the sine, the line, the answer into the sine quadrant. And that's 26.6 degree. Last step, we're going to count from 0 degree. Okay, that way and that way. Okay, so this angle is 180 degree minus 26.6, which is 180 minus 26.6 is 153.4. So theta equals 153.4 degree, or, okay, and this reflex angle is 360 minus 26.6 degree. 333.4 degree. So, or 333.4 degree. Okay, so you might have questions. Okay, the first thing is, how do I double check? Well, let's double check it. So double check. Okay, so let's do 10, 153, 153.4 degree. You should always do that. 10, 153.4 double check. So 10, 153.4. If you put a calculator, you get negative 0.500. So we know that's correct. It's not exactly 0.5 because this value is rounded 153.4 degree. Okay, and also you should do 10, 333.4 degree. So 10, 333.4 is indeed minus 0.5, so we know it's correct. Second question, what about the minus 26.6 degree? Okay, what about this answer? Is this not one of them? If you put 10, okay, 10, if you try 10, negative 26.6 degree, you would also get negative 0.5. But why is this not an answer, not acceptable answer or solution? Because theta is between 0 to 360 degree. Okay, so in here we'll say, okay, so we'll say minus 26.6 degree is not an acceptable solution. Acceptable. Sorry about my writing. Acceptable. My writing gets a bit mushy when I'm so excited to do maths. It's not acceptable solution because it is out of range. Okay, so the range is from 0 degree to 360 degree. Now, these little things are important in maths because it helps you, gives yourself an answer. Why is this? Why is this? So keep asking why, you know. So these two are the only solutions, right? So next, practice question 1. Okay, your turn. Pause video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Okay, so first of all, arc cos or inverse cos of root 3 over 2 on the other side, you get 30 degree, put in a calculator. Then you set a cos diagram. Okay, 30 degree is in here. And then when cos is positive, reflect in the cos region, cos quadrant. So 30 degree would go the positive angle again from 30 degree, and that angle here is 330 degree. So put in a calculator, cos 30 is root 3 over 2, correct. Cos 330 is also root 3 over 2. So two answers. Perfect. All right. Next one. Pause video, have a go. When you're ready for the answer, press play. Here are the answers. So first of all, inverse sine of negative root 3 over 2, you should get negative 60 degree. So when it's about a cos diagram, negative 60 degree means in the cos region here, cos quadrant 60. Okay, so if it's negative, we'll go the negative angle direction. Next, for sine to be negative, we should reflect it on the t or the tan quadrant. Okay, so therefore, when we count the positive angle direction again, that's 180 plus 60, that's 240 degree, and this is 300 degree. Okay, so these are your answers, by the way. So check your answer. Sine 240 is indeed negative root 3 over 2. So we're sine 300. And that, as you know, you got correct answers. Okay. Again, why is it minus 60 not an answer? Because it's out of the region. It's out of the range. Okay. Right. Example. Moving forward. Solve in the interval between x between 0 and 360 degree. Now this is important. We'll notice why later. For 5 cos x equals negative 2. So it's not always theta. You know, theta is not always the favorite Greek letter. Sometimes we use x as well. So to do this, quite simple. We just have to do the 5 divided by 5 over. So cos x negative 2/5. Okay, and do the same thing. So x equals inverse cos of 2/5 of negative 2/5. Okay, so if you put in a calculator, negative cos, not saying right, inverse cos of negative 2/5 is 103.6 degree. So as soon as we inverse cos, what should we do? Cos diagram. Okay, so remember this. We use cos diagram as soon as we inverse sine, inverse cos, inverse tan. Okay, so from now on, you expect to know more than one answers when you inverse sine, inverse cos, inverse tan. Not all equations have more than one. However, majority of them will have two, at least two. Some of them will even have 4, 5, or 6. Anyway, cos diagram. So 103.6 degrees. So how do we draw 103.6 degree? Well, CAST, we know that's 90, so 113.6 degree must be here. So we can work out the x angle here, do 180 minus that, which is 66.4 degree. Okay, so then we reflect in the correct quadrant. For cos to be negative, we have to reflect in the tan quadrant. That's 66.4 degree. So therefore the answer is in here, 103.6, and there. This one is 180 degree plus 66.4, which is 2, can't do mental maths. Don't trust my mental maths. 246.4 degree. So therefore, the answers, okay, so therefore x equal 103.6 degree or 246.4 degree. Okay, again, you should double check your answer. So if you do 5, sub in back here, if you do 5 cos 113.6 degree, that should give you roughly negative 2. So 5 cos 103.6. Yep, I get minus 2.00 something. So I know it's correct. Okay, do the same for 5 cos 246.4 degree. 5 cos 246.4 is negative 2 as well. So I know it's correct. That's how you double check. Okay, if you're happy with this, then next one, I thought it will be a practice. Not yet. I'll do one more. Right. Oh, this one. We have a sine and a cos. Right. That's why you have to remember the identity you've learned in a previous lesson in 10.3. Okay, so recall. Okay, so recall sine theta over cos theta is tan theta. So what can we do in here? If we divide both sides by cos theta, so sine theta over cos theta equals root 3 cos theta over cos theta. This one cancel out. So left hand side, you get tan theta equals root 3. So smarties like you would know how to carry on from here. If you want just an extra practice, pause video, be my guest. Have a go, okay? If you don't, I'll explain step by step as well. So first of all, inverse tan on the right-hand side, arc tan, okay, inverse tan. So put in a calculator, inverse tan of root 3 was 60 degree. As soon as you inverse tan, you should be using a cos diagram. Right, that's right, 60 in here. For tan to be positive, we should reflect in the tan quadrant as well, 60 degree. Okay, so that's 60 and that's 240. Okay, because that's 180 plus 60, 240. So theta equals 60 degree or 240 degree. Okay. Well, how do you double check your answer? Well, for this one, we should try something into original if we can. Okay, for this one to check our answer, okay, we should do sine 60. The sine 60 equals to root 3 cos 60. Right, so you do sine 60, which is root 3 over 2. Okay, and then you should do root 3 cos 60 on the right hand side. Root 3 cos 60, which is also root 3 over 2. So I know that's correct. Okay, do the same for 240. You'll get the same answer. Okay, so sub in the left and sub in the right, they both equal. Correct. Okay, next question, practice question 3. There are 4 parts of a question. If you need help, try to refer back to the previous examples, see if you're able to do that. Then pause the video, have a go at all the questions. When you're ready for the answer, you can press play. So here are the answers, okay, one by one. So question A, so first of all, divide 7 over, and then inverse sine, you get 45.6 degree. For sine to be positive, you should be reflected on the sine quadrant. So, and then that angle is 180 minus 45.6. I'll put in there 180 minus 45.6 degree in this line. That's 134.4 degree or 45.6 degree. So 2 answers. You must also write down your final answer in one line like this, okay? So you cannot just leave it like in the class diagram. So question B, divide by 3 over. Don't forget to put negative. When you inverse cos, you get 131.8 degree. So you work on the angle between x-axis, that's 48.2 degree. Then you reflect the line. For cos to be negative, it also is in the 10 quadrant. So this angle is 131.1, and this one is 180 plus 48.2, which is 228.2 degree. Okay. C, divide 3 over, and you get negative 74.7 degrees. So negative 7.4.7 degree, 74.7 degree means you go this way, okay? And then reflect in the sine quadrant because that's when 10 is negative. Then that angle we can see is 180 minus 74.7, and this reflex angle is 360 minus 74.7 degree. So you get 2 answers, 105.2 or 40 degree, or 258.3 degree. Okay, for D, slightly more complicated, but it's not undoable. Rearrange it, make it 3 cos theta, and then divide, etc. You make a tan theta equals 3 over 2, inverse sine, 56.3 degree. For 10 to be positive, reflect in 10 quadrant, and you get your 2 answers. Okay, so hopefully by using these 4 questions, you are more familiar to deal with trig equations, because these will become quite fundamental moving forward. And this could essentially be a 3 mark or 4 mark exam question in the beginning. Right. We're not done yet. Okay, so next one. Now, this time, what's different compared to previous one is you can see the range is different. Okay, so the range is different. Regardless, so let's try to carry on, do the normal thing first. Okay, so theta equals minus 5 over 7 degree, negative 5 over 7. So we'll do inverse sine of negative 5 over 7. Okay, so inverse sine of negative 5 over 7. So which is minus 45.6 degree. Okay, so minus 45.6 degree. As soon as we inverse sine, what do we need to do? A class diagram. Okay, so minus 45.6 degree is here. Okay, 45.6 degree. For sine to be positive, for sine to be negative, you should reflect it in, hopefully in your class diagram, you would have drawn the line here. Okay, so that's 45.6 degree. Next, let's find out the 2 solutions. So this one is 180 plus 45.6 degree. For this angle is 360 degree minus 45.6 degree. So why is it 360? Because if you go all the way down there. Okay. So you should get theta equals to 225.6 degree or 314.4 degree. Now we can't stop here, okay, because the range is different. So how many solutions do we get? So if we draw the graph, okay, if we draw a sine curve, okay, we draw a sine curve. So we know a sine curve looks like this. That's up to 360. That's up to 360, right? So therefore, that's up to 540. And this time we'll go to negative 180 degrees as well. So minus 180 degree. Right? So that's the sine graph between minus 180 degree to 540 degree. When y equals negative 5 over 7, That's somewhere here. So let's say this minus 5/7. So you get four solutions. 1, 2, 3, 4. So four solutions. So you don't have to draw a graph every time to know there are four solutions. So that's a longer way to show you there are four solutions. But what's a shorter way once you've done a class diagram? To find more solutions, okay, so in here. So, oh, by the way, I do have to explain to you. This is what we call the principal solutions. So make sure you write down. This is what we call the principal solutions. That means they are the original, they are the OG. Okay, so we're going to use these two as a base to find out more and more solutions. All right. So if we want to find more solutions, to find more solutions, okay, outside 0° to 360° of theta degree, okay, we can add or minus 360° to the principal solutions. Now, why 360, you may ask? Because every 360 is one cycle. Okay, therefore, if you add or subtract 360, you're finding a different cycle. For example, in here, okay, for example. So what we're trying to do in here is we're trying to find the principal solutions in this region, in the graph. You can see after 360°, that's the beginning of another cycle. And before the 0° is another cycle. So therefore, what we're trying to find the principal solution is the first cycle. So if we add in minus 360, okay, we can find the solutions if we add 360, we can find solutions in the next cycle and then the following cycles, etc. But if we minus 360, we can work out the answers in the previous cycle. Now, I'll let you think about this. In the principal solution, using this graph, can you tell me, should we add or subtract 360°? We should be subtract 360°. Because if we add 360, we are finding solutions beyond 360°. But from the graph, you can see from 0 to 540°, there are no more solutions beyond 360. However, there are two before the 0°. So we should subtract 360°. Okay. So in here, what we're going to do is we are going to subtract 360° to both solutions, Okay. So theta equals, so 225 minus 0.6 minus 360 is negative 134.4°. And if you do 314.4 minus 360 is, oh, actually, I should write down here as well, minus 360°, you will get minus 45.6°. Okay, so we check the answers against the range. They're all inside the range, so we're fine. So therefore, theta, we'll write its final answer. So theta equals to minus 134.4 minus 45.6, 225.6°, or 314.4°. So these are the four solutions. All right. Okay. And that's it for this question. Okay. If you're happy with this, all right. Oh, by the way, what about if we find more solutions? Say after 360, we could add 360°. Okay. If you try add 360° to it, you would just to explain. Okay. So if you add 360° to 225.6, 225.6° plus 360°, okay, if you do 225.6 plus 360, you get 585.6°. Okay, if you try to do sine, put it back to the original equation, okay, where we were given sine theta equals minus 5/7, put it sine 585.6, you get roughly that's negative 0.714 minus 5/7. So negative 5/7 in the calculator is minus negative 0.714, negative 0.714. So that's the same. So you can see this is a valid solution, but it's not valid in here because the range of values is between negative 180 to 540. So it is still acceptable, not acceptable, as it is a valid answer, but not valid in here. Okay, so that's how you can find more and more answers. Double check your answer. Obviously, you can put sine all of these angles to check if they're equal to minus 0.714. No, Okay, so if you're happy with this, pause the video, have a go at question. If you're unsure, you can pause the video, have a go at A first, and I'll show you the answer. When you're ready for B as well, if you want to do both, you can do both. Okay, pause the video, have a go. When you're ready for the answer, you can press play. Well, here are the answers. Here's the answer for question A, just for A. Okay, just to make sure you are on the right track before you do B. Okay, if you got wrong A, there's no, then you can try B again. So you inverse. So here the final answer. Only three answers, interestingly. Okay, so again, as I said, it's not always even numbers of solutions. There might be odd few. So in this one, because the range is from minus 180 to 360, so we inverse sign to now same thing. Do the cast diagram. Find the principal solutions. The principal solution is what you've done so far in the previous practices. Then once you find a principal solution, we'll look at the range. This time they go into negative. So I might as well do minus 360 degree. I'm not adding 360 because I already hit the maximum of 360 degree. That's the first cycle. So unless the upper limit of the range is beyond 360, then I might consider plus 360. But in this case, I'm not because the maximum already is 360. It's only 360. Whereas the minimum instead of 0, you have negative 180 degree. That means we're going into the previous cycle of the answer. So I do minus 360 degree to both answers. I do 150 minus 360 is minus 210. Minus 210 is out of the region, so I cross it out. Minus 360 from here is minus 30. So therefore, my answers are minus 30, 150, and 330. Okay. Obviously, you can argue, what about minus 330? We knew that from the get-go. Yes, you can. Okay. But here's just I'm presenting you a structure, a method that you can always follow every time to get the correct result. All right. So I will say again, inverse 10, cast diagram, find the principal solutions, and then do plus or minus 360, depends on the range. And then if it's out of range, cross it out and write your final answer. Okay. If I were you, I'll write down a few steps in here what I've just gone through to help yourself, to remind yourself, or put in the front of the notes, in the personal notes on the 5 steps or few steps on how to work out how to solve quadratic trigonometry equation, not quadratic. All right. Pause video for B. Have a go. When you're ready for the answer, you can press play. So here are the final answers. Okay, 4 answers. Here's a perfect example to show you why it's important we add and subtract 360 degree when the range is not between 0 and 360. So when the range is beyond 360 or less than 0 degree, it's time to add and subtract 360 degree to find out more solution, just to test it out. Okay, just to play safe. So you don't have to show these solutions, by the way. So again, sorry, I'll start again. Inverse cos 32.9 degrees, so cast diagram 32.9 degree. For cos to be positive, we should reflect in the cos quadrant. Then, so we found the principal solutions in here, these two principal solutions. Because the region is lower than 0 and beyond 360, I will add 360 degree to test it out. So when I add 360, I found out 392.9. I check it is within the region, so I can accept that. This one, if you sort of do your mental maths, 327 plus 360 is way beyond 440. So you don't have to show this solution. I'm showing this to you just to show you. You can work it out, but you don't have to. Okay, just for teaching purpose. But in a real exam, you don't have to show this. Okay, if you do, you have to cross it out. Okay, you don't have to explain why, but you have to cross it out. So in this one, you subtract 360 degree, you get minus 327.1. That's outside region. Cross it out. Do that, minus 360, minus 32.9. So we can accept that. So therefore, we have 4 answers. As weird as it looks like, we have 2 answers in different, one in the cycle after original and one before, and the cycle before the original. So we have 4 answers in here. Okay, you can put in the calculator, check it, cost each answer should give you around negative 0.84. Okay, right, I believe that's the end of lesson. No, one more. Okay, no, one more. Okay, this time, pause the video, have a go. The last one, I promise the last one, because I look at the next one is 10.5. So pause the video, have a go. When you're ready for the answer, you can press play. Right, for those who got stuck on how to begin with, here's the first half the answer so far. You have to rearrange it to make it 10 theta. Now, don't forget, when you divide by cos theta right hand side, it's 1, not 0. That's a common mistake. Okay, so it's 1. When you divide cos theta by cos theta, it's 1. So you get first answer 30 degree. Okay, so if you got this, well done. Carry on. So here's the final answer. Okay, so after we inverse 10, we get 30 degree. Do the class diagram, we get 30 degree and 210 degree as a principal solution. Now you can look at the upper limit is up to 720 degrees. So at 360, both answers give me 390 and 570. And then now because I can see 390 is is quite far away from 720. It's around 360 degree or more or less, away from 720. So what I would do is to play safe. I'll add another 360, just test it out, see if it stays inside range. But obviously, if you know your math sense, 720 is two region. Two region means there are four answers. So 1, 2, 3, 4, we have four. So adding 360 wouldn't give you any extra answer. If you don't know what I mean, just add 360 to see if the next answer stays within the range. Okay, if it doesn't, you can just cross it out easily. It won't hurt you, it just takes you 5 seconds. But also we notice that the lower limit is less than 0. So we'll subtract 360 degree to find solutions. And we actually found one, minus 150, because we do 210 minus 360 is minus 150 degree. So when you're at a final answer, you have 5 answers in here. Okay, and that's the end of lesson. Quite an important one, but well done for keeping it up to here. I'll see you next time.